This lab is based on solubility, and you're going to collect and record data and make different solutions. So solutions are a homogeneous mixture made up of a solute and a solvent. We're going to be making aqueous solutions where water is our solvent. Solubility is a physical property. It's defined as the amount of solvent or solute that can be dissolved in a solvent at a specific temperature. So this allows us to better understand an unsaturated solution, lower than the amount that could be dissolved in the solvent, a saturated solution where we have the maximum amount of solute dissolved in the solvent, and a supersaturated solution that is made by altering the temperature, heating it up so you can have more solute dissolved in your solvent than you would have at room temperature. For this lab, you're going to need a few of the things from your lab kit: a 50 ml graduated cylinder, those 2 beakers, a coffee filter, a temperature, the digital scale, and a glass stirring rod. On your own, you're going to need to supply some water, and it can just be tap water, your solute of choice, which you'll see in a minute, a string or pipe cleaner. I used a bamboo skewer in there with an elastic and a pipe cleaner, something to kind of allow your crystals to grow in this lab. Might need some tape to affix it. You'll need food coloring if you want to color your crystals. You'll also need a small saucepan and a heating element, so it could do your stove. I've just got a hot plate here in the lab. So you get your choice in the lab of the solute that you want. So we have borax here, and the chemical formula for borax. Epsom salts, which are magnesium sulfate. Pickling salt, I just use table salt, which is sodium chloride. And sugar, which is sucrose, it's a disaccharide. And those are your solutes. So in the background and theory, you're told the solubility of each of these solutes in water at 20 degrees. So you can calculate how many grams you would need to make 250 milliliters of solution. So I've shown it using dimensional analysis here, and you can take a look at that format and calculate that for your solute of choice. You do not need to do all 4 solutes, just the one that you choose. After that, we want to figure out how many moles per liter, what's the molarity of this saturated solution that you've calculated based on the solubility of the compound that you want to dissolve. And so I've laid this out with dimensional analysis. You will need the molar mass of each of the solutes. And so you might have noticed that before in the video, but I'll just give you that again. So we have borax, chemical formula, in the molar mass. We have Epsom salts, the chemical formula, and the molar mass. Salt, and the sugar that you're going to use. So again, with that, you're going to calculate the molarity of those solutions. So after you're done your calculations, then you move on to a few conceptual questions. This can take a little bit of sleuthing on the internet. A use of a supersaturated solution in a heat pack, a chemical heat pack, not like a magic bag where you put in the microwave. We're talking about chemical heat packs, or cool packs. They do exist as well. And then also a little bit of thinking about making a supersaturated solution and that recrystallization process. Something that's required is a nucleation point. And so that's kind of related to this question a little bit, and so it might take a little bit of thinking for that, and then you'll be ready to get into the procedure of the lab. So the first part of the procedure is pretty straightforward. What you're trying to do is use the calculated amount of solute to actually mix that into the 250 mils of water and make a saturated solution. So you're going to take one of your beakers and put it on the scale. You're going to press the Z/T, the tare button, to zero out the scale, and then you're going to put the amount of solute that you've calculated in your pre-lab questions into the beaker. After you've got that, you're going to use your graduated cylinder to measure out 250 mils of tap water and put that in on top of your solute. You're going to stir to dissolve. You want to take the temperature of this solution, and what you've tried to do is experimentally test that calculation of your solubility of the solute. So I've done 2 of these. I did the borax, and I've let this sit for a little bit. I took a temperature of it. It's not quite 20 degrees in the lab. I've stirred it, and it's been sitting here for a couple minutes. You can still see that there's some on the bottom. A lot of it has dissolved. So if you make a saturated solution, you want some of it dissolved, but you can make the observations and decide for yourself if your calculations held true and you made a saturated solution or not. The other one I did, I thought sugar would be really good to do because it would make something that was delicious. So I did the calculations for sugar's solubility, and it is an alarming amount of sugar that you can dissolve in 250 mils of water. So I wasn't even sure it was going to fit in the beaker. I have a glass beaker, but you can see it is the same size as your lab beaker. So you might want a bigger bowl or something to mix that in, but this is my saturated solution of the sugar solution. So again, I took the temperature of that and I could record the observations. You only need to do 1 of the different solutes, but just for demonstration purposes, I've got the borax and the sugar going here. So do record your observations for part 1. We're going to continue adding solute to, I'm going to choose the sugar again because I want to make something delicious, but I'll also do the borax. We want to make a super saturated solution out of these next. So moving on in the procedure, I chose to move on first with the sugar, and I can tell you my hands are already pretty sticky. I transferred from my beaker into a pot on my hot plate, or your stove you can do. We're going to heat that to a boil. We're going to make sure we clean out that beaker, which I haven't done because I'm short of hand right now, and we're going to add more sugar to our pot. So bring it to a boil, reduce the heat a little bit, just so it's under control, and add more sugar to that. You want to add it until it no longer dissolves. We're going to turn the heat off, and we're going to transfer that from the pot to another beaker. Now, if you can pour out of your pot, you can just leave it in there, but transferring this, it's quite hot and it can be dangerous. So we're going to transfer that to another clean, dry beaker, and then we're going to take that beaker and pour it into the jar that we're going to grow these crystals in. The jar that I've chosen, I don't think is big enough for the whole pot of super saturated sugar solution that I have going on, so I won't overfill that. But I do have that coffee filter in the top. You might need a friend or someone else to hold this. If you have like a cone or something to hold that filter, it's going to reduce the chance of you burning your fingers. So do take care with this step of transferring the solution to a beaker and then straining that solution into your jar. The reason that we're bothering to strain this is we want to avoid any nucleation point other than the stick that I'm going to have in the jar. We want the crystals to grow on the stick as our nucleation point, not at, the sludge at the bottom of the jar. And so that's why we're filtering that. I'm going to do this in the lab with the sugar solution and the borax, and I'll come back and show you the grown crystals. So I got curious. I was just going to do the sugar into the super saturated solution, but I got really curious and wanted to try them all. So I've just finished prepping up all of the solutions, first attempting a saturated solution. Pretty much across the board, I felt like I had more solute than was required, but my room temperature was also cooler than 20 degrees, so that could be a contributing factor. Then I transferred that material to the pot and heated it up, adding more solute, making a super saturated solution. I rigged up a bunch of funky ways of straining or filtering that to avoid too many nucleation points across the board. And I'll just give you a quick summary of what I'm finding here after I've just made this. I'm going to let it sit for a little while and see what happens. But right off the bat, the borax solidified really quickly, and you can see that even within the filter, it solidified. If I wiggle this stick, it's almost already fixed in place in my jar. I did make the borax blue. The Epsom salts were the last ones that I did. They're still filtering a little bit. I did dye that one as well. I've got my nucleation point in there. You can see it's just dripping and finishing, filtering. The salt, I realized I was using table salt, which is iodized, as opposed to the instructions say use pickling salt, which is non-iodized. But I got into it and I'm like, well, I may as well see what happened. And I made my super saturated solution. You can see that I've got crystals that have formed on the filter paper. So I'll give that some time. I also had on the surface some, I don't know if the camera can pick it up, but on the surface, there's a little bit of a film, and those are crystals starting already on the salt. The last one I was most excited about, I made a nice bright color, the sugar solution. That is a lot of sugar in that jar. So I made it into a super saturated solution, and I've got my little stick in there. True to the background stuff, this is the slowest one. Not a whole lot is happening, but I'll check back in with this in a little bit and we'll see what's happened. So I'm back with the results for this lab. I had a bit of a journey getting here, so it's been a little while since I filmed that last clip that you just watched. So these are my results. The borax pretty much crystallized immediately, actually in the filter paper. It's fully crystallized. In the jar, there are some crystals, mostly on, the outside of the jar. Not very much actually precipitated or solidified at that nucleation point, or the stick going in. The Epsom salts, I put a little bit of yellow in this one. The blue was dyed in the borax. In the Epsom salts, I actually had to reboil this one. So what happened was the initial solution didn't solidify at all. And so I put it back on the hot plate and added more Epsom salts and boiled it again. And I got a lot of crystals inside the filter paper. And my jar is almost completely solid. So real success on that, not really on the stick or the nucleation point. The salt, I was a little curious about this one because I had used iodized salt as opposed to non-iodized salt, like the instructions said. But regardless, I did get a little bit of success, and I actually got a little bit of the crystallization on my nucleation point, or on that stick. Also on the filter, curiously, there were crystals inside the filter and outside the filter. So as the solution was going through that filter, it was actually crystallizing. The sugar, there is a ridiculous amount of sugar in this jar. I colored this one as well, just for fun. This is what I was most excited about because it would be something that was edible. It also needed to be reboiled and have more solute added. I got a little bit of crystallization on the stick, but not nearly as exciting as like the candy sticks in the other videos online and such. I did kind of sleuth around at my house. My daughter has done this as a science fair project a number of years ago, and those were her results. So I helped her with that one, and I was unable to make mine work like that this time, but you might have better luck on that. She was motivated to do that, and then also made a geode cake. If you're into cake decorating, I guess this is quite the thing. So anyway, that's what motivated her rock candy creations. So you can take a look at my results. Give one a try yourself. I think doing 2 solutions would take a long time, and certainly not doing all 4 of the solutes. My analysis and conclusion would have to be changed a little bit for the lab as I've got it going here. So you could reflect on that initial making of the saturated solution. For mine, I did make a saturated solution, but I think I overshot the mark with adding as much solute as I had calculated. For number 2, it had asked you to do multiple trials, and I think doing this twice is a lot. You might have to reboil yours, so you could reflect on that. You could also compare your solution to the ones that I just showed you, rather than doing this all twice. And you might be able to hypothesize what caused the difference in what you would see. The answer in cleaning this stuff up, which I had sugar all over everything in the lab, and I used that. And then also as a last one, if you were to do it again, what would you do differently and why? And there's lots of options about what might be different to get better results in this lab. So I hope you had some fun, And I hope you had better results with something that was delicious or interesting or beautiful than I did.